Hi, class. So I just wanted to meet you real quick and kind of go through one of the problems in section 2.3 that seems to be catching a lot of people off guard. So it's one that you will see in the quiz, and then you're going to see it again on the test. So it's very important that you understand how to do it. So this is one of the examples. And it is both on 2.3, the homework, as well as the quiz that covers 2.3. So let me just walk through it with you and show you how it needs to be done. Okay, so here's the scenario. A company manufactures microchips. There's your revenue function. There's your cost function. And then you're going to use these two functions to answer parts A to D. So the first question, and then you always want to identify what your variables represent. The X is the number of chips in millions, okay? The R of X and C of X, so the revenue and the cost are in millions of dollars. So if I get my answer as 2 for the revenue, that means it's 2 times a million, so 2 million. If X is, 1.5, then that means it's 1.5 times a million. So it's 1.5 million, okay? Or 1.5 million. 1,500,000, if you will. Okay, so the first question, oh, and the domain is between 1 and 20. So that means we have between 1 million chips to 20 million chips. Okay, so always identify what your variable represents, and then what is it in? Is it in thousands, millions, hundreds, whatever it is? All right, so to find the profit function, so remember, profit is always the revenue minus the cost. So we have our revenue function, and I'm going to go ahead and distribute this X through. So our revenue is 72X minus 4X squared. And I can rearrange this so it is in descending order. So negative 4X squared plus 72X. And then our cost function is 123 plus 13X. So the profit is my revenue minus my cost. Notice I'm putting it in parentheses. If I don't have the parentheses here, you can see that I'm just subtracting the 123. But what I'm actually doing is subtracting all of the cost. So when I do that, that negative gets pushed through both. So my profit function is negative 4X squared. And then I have 72X minus 13X, which is 59X, and then minus the 123. So this is my profit function, okay? That's what we're going to use, profit, revenue minus cost, all right? The next part says, and I'll get to the graph is in there also, but I'll get to the graph in a minute. The next part says, find the x-intercepts of profit to the nearest 1,000 chips, and it means find the break-even points to the nearest 1,000 chips. Well, it's the same thing. X-intercepts is the same thing as break-even. So the way you find that is either through factoring or quadratic formula. So since this one won't be easily factored, I'm going to go ahead and use the quadratic formula. So remember, quadratic formula is x equals negative b plus or minus b squared minus 4ac all over 2a. Okay, so here is my a, here's my b, here's my c. This is why it's important to write it in descending order, the exponents in descending order. All right, so here we go. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, now it's a matter of order of operations. All right, think of the square root sign as parentheses, right? I'm going to do everything underneath that square root sign first. So I have negative 59 plus or minus. I have this all done ahead of time. 59 squared is 3481 4 times 4 times 123 is 1968. And I am subtracting. That didn't work out very good. Let me move this. Okay, so I have x equals negative 59 plus or minus the square root. 59 squared is 3481. 4 times 4 times 123 is 1968. I know it's a negative because I have 3 negative signs. 1, 2, 3. That makes the whole thing negative. If I had 2 negatives, it would make the whole thing positive. Okay, and then all over my -8. So again, I'm going to find what's underneath my square root sign first. So 3481 minus 1968 is 1513. Okay, now you have 2 answers here. You have negative 59 plus the square root of 1513 all over -8. And we'll get that answer. And then you have negative 59 minus the square root of 1513 all over -8. So the plus version is 2.5128. It says to round to the nearest 1,000 chips. So that's this point right here. So 2.513. Okay, that's how many chips. And then this one, the negative version, is 12.237. Okay, so there's the number of chips that will make you break even. So remember, what we're doing is we have a revenue and we have a cost. What you just found were these two values right there, the break-even points. It's where the revenue and the cost are equal to each other. Okay? This is the part that most people are struggling with. When you're finding the maximum or the minimum, this is key. Maximum or minimum means vertex. Okay? And again, you're not completing the square, you're using the vertex formula. Okay, so remember the vertex formula, to find the x, you go negative b over 2a. To find the y, you plug that answer back into the original function. Okay, so notice these two are completely different. When you're finding the break-even or the x-intercepts, you're using the quadratic formula. When you're finding the maximum or the minimum, but in this case the maximum, you're using the vertex formula. Okay, so vertex of the maximum of the profit, which means you're going to find the vertex of the profit function. So the profit function, I'll write it here so we can see it, was negative 4x squared plus 59x minus 123. So maximum of the vertex, or I'm sorry, maximum of profit, we're going to find the x value. So negative 59 over 2 times negative 4. So negative 59 over negative 8 is 7.375. Okay, so this is the number of chips that produces the maximum profit, 7.375. And remember, the number of chips, or the x value, was in millions. So if I multiply this by millions, that means this moves over 6 places because there's 6 zeros in a million. Okay, all right. Then to find the maximum profit, we plug our value back into our profit function. Okay, so when I calculate all of this, I get $94.5625 million. Okay, so we're rounding to the nearest $1,000. So we're rounding to here. Okay, so 94.563, 94.563. Okay, to 3 places. That's what we're rounding to. All right, that is our maximum profit. So maximum profit happens when I have 7.375 number of chips. My actual maximum profit is $94.563 million. And then compare that to the maximum revenue. So maximum revenue means I am finding the vertex of the revenue function. So remember our revenue function, I'll write it here, was negative 4x squared plus 72x. That's our revenue function. So to find, excuse me, the vertex, we have to find our x value first. So negative b over 2 times a. And that ended up being 9. Negative 72 over negative 8 is 9. So 9 million chips. And then to find our y, we plug that back into our revenue function. And we end up with 324. Okay, so $324 million. Okay, now the question is, we're comparing it. Well, obviously 94 million is way less than 324 million. So as a business person, what's the difference? The difference is your cost. Remember, revenue or profit is your revenue minus your cost gives you your profit. So if you have revenue, everything that comes in of 324 million, whatever goes out, the difference is your profit. Okay, so yes, profit should be less because you are going to have to pay out costs in a business. Okay, now real quick, the way you're going to find your graph is, first of all, notice your cost function, right? So we had our cost function was 123 plus 13x. This was in pink. Okay, that's, oh, I'm sorry. Yeah, that's our pink, right? That's our pink line. Our revenue was negative 4x squared plus 72x, and that is our blue. Okay, that's our blue parabola. And then our profit was negative 4x squared plus 59x minus 123. Okay, so this is our profit, and that is our green parabola. Okay, so when you just look at it, this one looks like a good example, right? We know that our maximum revenue, okay, so our maximum revenue was 324 million. Well, here's 360 here, so we're pretty close right there, so we're good there. This one over here, our maximum revenue was way less, so we know this one's out. Okay, it cannot be that one. We also know that our cost function has a increasing slope, a positive slope. So this one has a negative slope, so it can't be that one. So now we have to choose between here and here, all right? So now look at your profit. Remember, profit was 94 million. So the vertex was at 94 million. Here, the vertex is up here at, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So at about 40,000, right? So this is too high. This down here is closer. So this is the correct one. So you don't have to do a lot of math when you're looking at these graphs. Just logically think them through. You can get rid of them based on what they're showing. If they're showing a negative cost function, it's out. If you're showing a cost function that does not intersect with the revenue, that's out, okay? Over here, you can look and go, okay, where is my break-even points? Remember, we found our break-even points, and our break-even points were at 2.5 and 12. So if this is up to 20, that means these are about 2 each, 2, 4. Yeah, so here's break-even here, here's break-even here. So there's ways to eliminate what you can look at, okay? All right, I just want to do that real quick. Hopefully that will help.